Сейчас. Вот.
Okay. So, dear Praveen and dear listeners, we are start the meeting of the special seminar, scientific seminar, titled as Intellectual Theatre, and we invite the famous professor from Jaipur, Praveen Agarwal. So please, Praveen, could you talk, tell us about what you are going to talk, and so, and welcome. You have 20 minutes or 25 minutes, and then we probably will have question if we understand everything, something. Okay.
Okay, perfect. So give me a minute.
Yes,
Please give me a permission to share the screen.
Yes, just a moment, please.
Yes. हाँ जी. थोड़ी देर बाद 20 मिनट बाद है ना कोई टॉक चल रही है मेरी. Yeah, I'm not able to share my screen. Professor Ruzana.
Yes, I'm trying to find how to do this. I will make you an organizer for this, and you will take everything what you need. Okay. So now you are an organizer of the conference. Okay. And you can share
perfect.
with us your...
Perfect. So I hope my screen is visible.
Yes, yes, it's in process.
Yep. Now it is visible.
Yes, we can see the screen.
Yes, it's perfect.
So first of all, I am very thankful to the all the organizing committee members of the People's Federation University of Russia, that is called the РУДН University, to inviting to me in the seminar series to give and present my work, in which I have tried to share some glimpse of my ideas and some kind of my recent works. Those are related with the philosophy and the philosophy of the mathematics, and as well as my directly connected with some operators of the fractional operators, that is called the differentiation and integration operators too. So you can see that if we want to see my city, so I am not going on these details because in the next time when I am coming to the physically, then I can show to the all the things. So outline of my talk is the abstract, introduction to fractional calculus, functions used in fractional calculus, objective of my investigations, extended fractional differential operator and their applications, fractional integral inequalities, and proposed future research plan. So in this talk, we aim to discuss the philosophy of mathematics and some related works on fractional operators. As we all are aware, philosophy is the very rich area of the scientific fields. And when we are talking about the philosophy of mathematics, then what do you mean by the philosophy of mathematics, which I have described in my next slides, and then I can connect my fractional operators with the philosophy of the mathematics. After that, we study the extended fractional differential operators such as the Riemann-Liouville and Caputo type fractional operators involving the generalized hypergeometry functions introduced recently and their properties. Moreover, we as well study certain fractional integral inequalities associated with the well-known Polya-Saigo and Chebyshev type inequalities. At the end of this talk, I shall be briefly propose the plan of my future research work, which is try to connect with the interdisciplinary areas of all the sciences, arts, and yes, especially with the mathematics. In mathematics is regarded as a science, then the philosophy of mathematics can be regarded as a branch of the philosophy of science, next to discipline such as the philosophy of physics and the philosophy of biology. However, because of its subject matter, the philosophy of mathematics occupies a special place in the philosophy of science, whereas the natural sciences investigate the entities that are located in the space and time. It is not at all obvious that this is also the case for the objects that are studied in mathematics. In addition to that, the method of investigation of mathematics differ markedly from the methods of investigation in the natural science. Wherever the latter acquires general knowledge using inductive methods, mathematical knowledge appears to be acquired in a different way by deduction from the basic principles. The status of mathematics knowledge also appear to differ from the status of knowledge in the natural science. The theories of the natural science appear to be less certain and more open to revision than mathematical theories. For these reasons, mathematics poses problem of a quite distinctive kind of philosophy. Therefore, philosophers have accorded special attention to orthogogy and epistemological questions concerning mathematics. On the other hand, philosophy of mathematics is concerned with the problems that are closely related to the central problems of math physics and epistemology. At first blush, mathematics appear to study abstract entities. This makes one wonder what the nature of mathematics and entities consist in and how we can have knowledge of mathematics and entities. If these problems are regarded as inspectable, then one might try to see if mathematical object can somehow belong to the concerned word after all. On the other hand, it has turned out that some expert it is possible to bring mathematical methods to bear on philosophical questions concerning mathematics. The setting in which this has been done is that of mathematical logic, when it is broadly convinced as comprising proof theory, model theory, set theory, and computational theory as subfield. Thus, the 20th century has witnessed the mathematical investigation of the co-sequence of what are the bottom philosophical theories concerning the nature of mathematics. When professional mathematicians are concerned with the foundations of their subject, they are said to be engaged in foundational research. When professional philosophers investigate philosophical questions concerning mathematics, they are said to contribute to the philosophy of mathematics. Of course, the distinction between the philosophy of mathematics and the foundations of mathematics is vague, and the more interaction there is between philosophy and mathematicians working on questions pertaining to the nature of mathematics, the better way. In recent years, many extensions and generalization of fractional operators involving the spatial functions are the witness a significant evaluation. This modification in the theory of fractional spatial functions offer as an analytical foundation base for the many problems in mathematics, mathematical physics, and engineering science, which have been solved absolutely and which have various practical applications. The theory of fractional calculus revolves around the differentiation and integration to an arbitrary order. So why I am taking this topic on today's seminar, because in the philosophy, we can presume something and we are giving the some different kind of aspect as per our experience. That is called the philosophy. If we are talking about the fractional operators, then yes, presently there is no geometrical phenomena is available for the fractional operators. So that's why it is also going in the philosophical way. Some of the researchers are using fractional of calculus as a part of the tool like a language. They are using the fractional operators to solve their physical phenomena with the help of the fractional calculus. Some of the scientists are having the different opinion. They are not convinced with the fractional calculus because its geometrical interpretation is not available. So that's why, but as per their problems, they are using the fractional calculus operators to solve their some kind of differential equation problems and to find the significant solutions. So that's why I am taking this area on for the today's talk. If we are talking about the fractional calculus, then you can see that the nth derivative of a function dn fx is represented by d raised to power n dx n fx. If we are talking about the beginning of the fractional calculus, then I am talking about the 1695, year 1695. Very famous scientist Al Hospital inquired to Leibniz what meaning could be ascribed to dn fx if n were a fractional like n equal to half. This is the beginning of the fractional calculus, and you can see that it is the beginning of the thought process, how a mathematician thought like a philosopher and give the some kind of assumption, how we can put the value of the n will be fraction, then what happened? So Leibniz' answer to this query was an apparent paradox from which one day useful consequences will be drawn. It is assumption by the Leibniz. So this is a philosophical answer by the Leibniz. Someday it is become the somewhat of the useful consequence in the field of the mathematics and the science. And now after the 200 years, after the 200, 300 years, now it is a true. In last 100 years, many mathematicians, scientists are working in the field of the fractional calculus and developed its utility. If I am talking about the some kind of contribution, initial contribution, then I am using the one of the well-known development by the Leibniz in 1697. Leibniz mentioned in his letter to J. Walsh and J. Bernoulli about the possible approaches to the fractional order differentiation in that sense that for non-integer values of n, the defined could be the following. He is using the function of fx is by the exponential function e raised to power mx, and if we are differentiate up to the nth time, then the resulting term comes in term form of the m raised to power n e raised to power mx. On the same way, in 1730, Professor Euler is giving the very important and useful result that is called the Euler's contribution, which is a very remarkable in the field of the fractional calculus and new era of the science, because he is using the very, very well-known formula when x raised to power n variable is differentiate up to the nth time, then he is having the some kind of relation which is given by the m into m minus 1 up to the m minus n plus 1 x raised to power n minus n. On the same time, he is using the some kind of the gamma properties. Gamma is the family member of the spatial function. Then he is using this property gamma m plus n equal to m into gamma m minus m into m minus 1 up to the gamma m minus n plus 1, and then using the some kind of simple computation, then he found the very interesting result. dn x raised to power m upon dxn equal to gamma m plus 1 upon gamma m minus n plus 1 x raised to power m minus n. My point is that this formula is called the composition formula. It is a very powerful formula. Nowadays, most of the mathematicians, those are dealing with the fractional calculus, they are using this well-known composition formula we call the image formula also. And the beauty of the formula you can see in the below steps. If we are putting the value of the m is 1 and n equal to half, and using the some kind of basic definitions of the gamma function, then we immediately got the very interesting result. D half x upon dx half is becomes under root 4x upon pi. Very beautiful result. It is given by the Professor Eulers in 1730. After that, J.B.J. Fourier in 1820, he is the first step to generalization of the notation of differentiation for arbitrary function was done by the J.B.J. Fourier. If we are talking about the another contribution, then Livoli was the first to point out the existence of the right side and left side differential and integrals through his three approaches. After that, Professor Riemann in 1826 is giving the very well-known important result, which is remarkable and giving the truth in the direction of the Leibniz contribution. That is called the initialized fractional calculus was born latterly in the later half of the 20th century. Riemann notation is as follows with the complementary function. So if we can say that in the Cauchy formula is a well-known formula in the complex analysis. He is giving the Cauchy formula of n derivative in complex variable. Then we are getting the result in the terms of the factorial n upon 2 pi j contour integral f tau upon tau minus z raised to power n plus 1 d2. And I am happy to share with you now this is the main formula to find out the solutions of the any kind of fractional operators. When we are dealing with the fractional operators, most of the time we are using the same approach of given by the Cauchy-Riemann, that is called the well-known Cauchy's formula. Since that time, the fractional calculus has drawn the attention of many famous mathematicians such as Euler's, Laplace, Fourier, Abel, Livoni, Riemann, and Laurent. But it was not until 1884 that the theory of generalized operators achieved a level in its development suitable as a point of departure for the modern mathematics. By then, the theory had been extended to include operators d nu, where nu could be the rational or irrational, positive or negative, real or complex. Thus, the name fractional calculus becomes somewhat of a misnomer. A better description might be differentiation and integration to n arbitrary order. And after that, up to the 19th century to 2016, or I am sorry, it is a typing error, it is a 2022. It is a practically impossible to name all the made important contribution in construction of the early stage of the building of fractional calculus. New era in the development of this branch of science began 50th to 60 years ago due to numerous applications of fractional type model, and it is continue up to the now. One can mention a large list of areas of application as follows. So my point is that this fractional calculus is also directly correlated with the philosophy of the mathematics, where as a being of philosopher, when you deal with some problem, then you have a predict and giving your different opinion on the particular situation. At the same time, in around the globe, many scientists and researchers, they are using the fractional calculus in their different approaches and solve their basic problems. So that's why it is a very important tool nowadays. And recently, Stanford University is announcing the fourth list of these highly cited researchers around the globe. And I am happy to share with you, I am also part of this list, as well as most of the mathematicians and scientists those are working in the field of the fractional calculus, they are also member of this particular list. So it showcases fractional calculus is a diversity. It has a diversity. It is capable to solve with some viscosity problem, medical problems, biology problems, engineering problems, as well as to connect with some of the philosophical issues that we can solve with the help of the fractional calculus in the coming days. So this is my point, and I am not going so much mathematical part. I am directly going to the, yeah. So this is the related publications of my study. This is my references. You can see that all are the published in the reputed journals. These are my papers which already have been published in a reputed journals, which showcase that this area of the research is very, very well known and very important. So these are my references. Now in future, to define the fractional Q calculus operator appropriately with the view of the applying these operators in the geometric function theory of complex analysis, study and investigate geometrical properties of such functions like coefficient estimate, radii of close to convexity, star likeness, convexity, and disjoint properties. I also plan to explore the possible applications of the Q calculus to obtain the source of the certain spatial type of fractional Q integral and Q difference equations involving Q functions. To study and investigate certain fractional integral inequalities involving the fractional Q calculus operators. I am also trying to investigate and derive the new result in the field of the fractional Q calculus operators for extending all the important results involving classical function, fractional calculus operator, and integral transform to their Q analogs. To explore the possible applications of the Q calculus to find result in signal and image processing. Applications of Q calculus to find results, system identification and control theory, as well as the finding integral formulas for simplification of integral representation involving various spatial functions, including Metaglepper functions. Further obtained results, we are planning to apply at study direct and inverse problems for fractional order mixed type differential equations. Possible generalization of these formulas will be discussed in the sense of application at study degenerating fractional order partial differential equations. I am very thankful to the Ministry of Science and Higher Education of the Russian Federation and the People's Federation University of Russia for providing the grant. Awarded number is 07515202163. I am very thankful to all the participants for listening carefully, and if you have any kind of question, then most welcome.
Praveen, could you make me an organizer of conference?
How I can do? Can you tell me?
Just yes, you will go to participants, and against my family, I mean this green avatar. Mm-hmm.
Yes,
and make me an organizer.
Just me.
Okay.
Then make host, right?
Yes. Host. Yes. Okay. I'm already an organizer.
Okay.
Just I will just. Okay. If any questions or some remarks, my dear philosophers, everything is clear with mathematical issues. Полина. Okay, thank you.
Can I ask something? From this platform, I request to all the participants. First, in these days, I saw the many applications of the fractional calculus in directly related with the philosophy. As I told you, when we are dealing with the philosopher, as a being of philosopher, you all are the well-known philosopher. You have the some kind of perspective in particular ideas. Okay, when the some activities happen, then different philosopher is giving their own opinion about the particular situation. On the same thing, in these days, fractional calculus is also very important function and very important field of the research. So we can use the fractional calculus to find out the some philosophical direction. I can suggest the some of the direction via mail to the Professor Ruzana, and then I request to all of you, you can go through the particular direction and just in the philosophical way. The mathematical part I can do, there is no issue, but in the philosophical part you can deal with this my idea, which I have share I will share with the Professor Ruzana.
Okay, thank you very much, dear Professor. So I think that today we can finish or complete our meeting because we have some time to think about this. Yes, and I think that when we come to Jaipur, I hope this November, we will talk in details about your school scientific theme. Okay,
100%.
so thank you very much, dear Praveen, and thank you, my dear listeners, dear participants of the seminar. I hope the next time we will talk about probably history of mathematics in India, and I think that not only our dear Professor Praveen will talk, but also me or my colleagues also will talk about mathematical issues in Indian philosophy. It's a very interesting theme, and I think it will be very fruitful for our collaboration in the future.
Definitely, definitely.
Okay.
Thank you very much.
Okay.
Thank you very much.
Thank
Bye-bye.
you. Bye-bye.
Bye-bye.
Okay. Thank you very much. Good luck.